The market in the Spanish port of Corunna is a distribution point for many kinds of fish, but it only gives a glimpse at the mysterious creatures which dwell in the Atlantic Ocean. Blue sharks are common, and there are many kinds of shellfish. But commercial fishermen can only harvest the surface layers. The depths of the world's oceans are largely unexplored. While millions of dollars have been used to hurl scientific equipment into space, only modest sums have been spent to probe the abyssal zone, an enormous uncharted area of our own planet. This research vessel is equipped with a high-tech trawling system. The researchers aboard are on a mission to catch strange and rarely seen creatures that inhabit the ocean's depths. The net will fall to a depth of over 2 kilometers. Here, the water is permanently cold and dark. The predatory fish which live at these great depths have one thing in common: huge mouths equipped with large teeth. They don't encounter prey very often, so must be able to catch and eat anything, including creatures larger than themselves. This sample will be from over the Iberian abyssal plain, 500 kilometers off the Spanish coast. Here, in places, the water is 7 kilometers deep. Above 1.5 kilometers, the water temperature varies, but below, it's constant, at 0 degrees centigrade. It isn't frozen, because salt water freezes at a lower temperature than fresh water. It takes 4 hours to complete the trawl. During that time, the weather can turn unpleasant, but the ship's equipped to work in anything up to force 6 winds. The laboratory tables are gimbaled to remain level despite the movements of the ship. The course is maintained by a computer which can use the engines and steering gear to hold the ship completely stationary without drifting, even in a storm. During the haul, the computer holds the ground speed of the ship steady, but because there's a surface current, she's hardly moving through the water. The instruments indicate that there are over 4.5 kilometers of cable to pull up. On this haul, the mouth of the net will be held open while it's brought up, taking everything in its path. The crane is swung into position, ready to haul the net itself aboard. No one knows exactly what surprises will come up from the ice-cold darkness. At the top end is the monitor, which receives signals from the ship to control the net. Then a small sampling net, and finally, the big trawl itself. Opened into its working position, the net is the size of a small room, and it's sieved through a column of water 16 kilometers long during the 4-hour trawl. After all that fishing, the catch can be contained in a small plastic bucket. Although the ocean deeps contain 9/10 of all the water in the world, they are very sparsely inhabited. Deep-sea animals live isolated lives in a boundless world. Whether they go up or down or sideways, It's rare that they meet another animal, and if they do, it's likely to be a different species. Consequently, the catch from a 16 kilometres trawl through these deserted deep-sea spaces is not very big. Many of the animals that are brought to the surface die due to the changes in temperature and pressure. Each scientist has his own speciality, but has also acquired a general knowledge of what to expect. They're always on the alert for new creatures. A rather shapeless black fish is typical of the deep seas. Living in such a stable environment, without boundaries or currents, deep-sea animals do not evolve the more complex patterns found at higher levels.
Okay, right, now I'm in
The larvae of an eel on its way from the Sargasso Sea to an estuary somewhere in Western Europe. It's not a deep-sea animal at all. The eel still needs a fully developed skeleton and a beautifully symmetrical muscular system for its long journey. Part of its future travels will be over land, but in its early days, it's an ocean dweller. The distant ancestors of all animals with backbones may have been like these curious creatures, known as salps. In deep water, there's many different types of salp, most of them less than 2 centimetres long. They move about by sucking water in and squirting it out under pressure. Some species go about joined together in groups or colonies. This rather primitive arrangement has been improved on by other salps, in which the shape of each individual is fitted to its place in the colony. A parasalpa colony looks almost snake-like. Cyclosalpa's wheel-shaped colony looks more like a jellyfish than a collection of ancestral vertebrates. The individual salps have an enemy down in the darkness, a little shrimp called Phronima. Phronima attacks and eats salps and other animals like them, and uses their outer casings as a place to rear its young. The youngsters hang in a cluster in the roof of the case, while their parent uses its legs to circulate water round them. As the young Phronimas grow up, they'll wander round their glass house until they find their own way out. Until then, the parent keeps it clean. Because there's so little light at these depths, the colour of deep water animals is a mystery. Red is common, but no one knows quite why. There's little or no daylight to see it by. Even so, many deep water invertebrates, including Phronima, have large compound eyes made up of clusters of transparent rods. Another shrimp, Cystosoma, has huge eyes. Although its tail is obviously shrimp-like, its head looks more like a horsefly. The slender rostrum of Streetzia leads to even more highly developed compound eyes. Although their world is pitch black, many of these creatures produce light to attract a mate or prey. Their eyes may be important for catching a distant flash or glow. Touch is probably as important as sight. The antennae of this shrimp, called plesionica, are probably used to pick up vibrations made by both prey and predators. Moving slowly through the blackness, the deep water shrimps somehow survive and breed, even though they have to do without light, warmth and contact. The blue-green clusters on Plesionica's legs are its eggs. These are euphorsiids, producing flashes of light in a darkened laboratory. They are better known as krill, the staple food of the great baleen whales. Out on deck, preparations are being made for another trawl. The net will bring back with it creatures from a world which is less well explored than some parts of the moon's surface. This time, the mouth of the net will be closed 1.5 kilometers below the surface before it's pulled up. Whatever is in it then can only have come from the zone of total darkness over the Iberian abyssal plain. In the lab on board ship, the scientists are kept busy day and night, sorting out the creatures brought up by the deep-sea trawls. Every 4 hours or so, the net brings up a new sample. Among the catch this time is a snipe eel. In the sea, it hangs vertically in the water, head up, ready to grab passing deep-sea prawns and shrimps in its sensitive, saw-toothed jaws. Its jaws diverge at the tip, probably to increase its chances of touching a passing shrimp. It relies on touch to locate its prey in the dark. From shallower water, 3/4 of a kilometer deep, one of the earlier trawls brought up a hatchet fish. It lives in the so-called twilight zone, where it's not completely dark. It can produce a faint glow of light from a double row of light organs, the pink dots on its undersurface. Each dot has a reflector behind it and a lens in front, accurately aligned to point downwards. They're shaded from the side so that they can only be seen from below. They help to break up the fish's silhouette against the very faint light from the sky, without giving it away to predators, or victims, approaching from the side. Some fish in the new catch from the dark zone also produce light, but not necessarily for camouflage. This anglerfish has a feathery lure glowing above its mouth. Then there's Opisthoproctus. This specimen was dead when it reached the ship from jostling in the net. Its eyes are positioned to look up, but like the hatchetfish, it shines its light downwards. The light's evenly diffused over its underside by a sheet of transparent tissue. Although Opisthoproctus lives for most of the time in the zone of total darkness, it migrates upwards to feed by night. Perhaps that's when its camouflage comes into use. In the deep ocean, fish have to grab every chance of a meal. This is why many of the predatory species have huge mouths and lethal-looking teeth. Another predatory fish, called Stomias, also has a luminous lure. Although, like many deep-sea fishes, it has huge sensitive eyes, its jaws are triggered not by sight, but by anything that touches its bait. Its array of light organs suggests that Stomias too migrates upwards at night. Every so often, another fish must mistake the lure for an edible creature. The deep trawl brought up some squids as well. This one, called Histiotuthis, lives over 1.5 kilometers down. It's a lopsided creature. Its left eye is 4 times as big as its right eye. Nobody knows why. The animal's been well known for years. The old whalers knew that it's the main food of sperm whales, but it was only when modern deep trawl nets came in that anyone realized how deep the whales dive to get it. The squid controls its depth by fluttering its fins and moves along by jet propulsion.
Okay, right, now the
These little round creatures are called Gigantocyprus. They have very strange eyes. They are surrounded by parabolic reflectors like car headlamps, and they pulsate. The animal itself is an ostracod, a relation of the shrimps, which lives in a shell. This is a female. Her shell is full of pink eggs. Usually ostracods live in fresh water and are about 1 millimeter across. These, from the deep ocean, can be as much as 2.5 centimeters in diameter. Gigantocyprus uses its antennae to swim, but what it uses its elaborate eyes for, down in the darkness, is a mystery. It doesn't hunt, it's a filter feeder, and it can't avoid any fish that might want to eat it because it swims too slowly. This is Spirula, a primitive mollusk. It's halfway to being a squid, but it's only 4 centimeters long. This was the first one ever to be hauled up intact. In the middle of the fluttering fins at the top, there's a light-producing organ. The same haul produced a transparent squid called Japotella. It maintains its position in the water by means of a buoyancy sac filled with ammonia. It attacks anything it can bump into, with its horny beak located in the middle of its tentacles. The deep sea is where fact appears to merge into science fiction. Down in the depths, there's a seemingly endless stream of improbable alien beings floating in a void. Pteropods are creatures that seem to dance on the edge of another dimension. Pteropods are mollusks, like snails and squids. Their name means wing feet. They fly through the water using flaps formed from their foot. Their internal anatomy is just like a snail's, but externally, they look out of this world. This one's called Cleone. Like the others, it hovers in mid-water, feeding on the detritus drifting down from above. They look like angels, fluttering in a black and starry sky. When pteropods die, they sink, and their shells in countless millions cover the bottom of the deepest oceans. This time, the winch is dragging up the bottom sludge with a sample from the very bed of the sea, at this point a little over 3¼ kilometers deep. It's a grey porridgey substance that looks almost lifeless. A tub of it is carried to the lab for sorting. Although no plants can live there, it's too cold and dark, the bottom of the ocean has a surprisingly rich and varied animal population. Some of the commonest animals down among the pteropod ooze are brittle stars. They are deep-sea relatives of the more commonly seen starfish found in tidal pools. Like many other creatures of the abyss, they produce their own light. The deep seabed must be a wonderful sight. Deep water corals grow on the bottom, and they too produce light. Moving against this luminous background are some eerie animals, like this sea spider, 25 centimeters across. Judging from the contents of the dredged-up material, the seabed seems to be dominated by lobsters and shrimp-like creatures. This is a snapper shrimp, a powerfully built little predator. This one is equipped with various pincers, spines, and feelers. It's practically a living Swiss Army knife. A squat lobster is the deepest living crustacean. It dwells permanently on the bottom, with its tail tucked under it like a crab. Carrying its collection from the world of darkness, the ship steams home in the sunshine. Back at Corunna Market, the king prawns, langoustines and scampi are just more seafood commodities. It's easy to forget the completely alien world they come from, a place that may seem to have more in common with the dark outer reaches of space than anything on this Earth.